Hi YouTube. Now here is my setup. This testing setup intended for all of my technology, like fuel savings. I will run this Indian gasoline engine as a genset, and this is the dynamo, and that's the engine, and that's my fuel injection, the long stainless, and here is my HSO, and that's my fuel injection, my own design fuel injection. This is a very versatile laboratory testing equipment, like, you know, the dyno tester. So what we're gonna do, we just run it and then check the fuel, and then here's the graduated plastic. You can see the measurement. This is 1 liter, so we know, and then there's a time, we will time it. And this is act like a dynamo, although this is not a dynamo. This is a motor, a BLDC motor, but we are loading it. So if we want to know the efficiency of what I'm doing regarding fuel savings, I can know easily and accurately. And now here is my setup. Now this is my DC motor. If you remember, I use it for my, you know, testing my electric car with Department of Energy. And this is the battery, but that's why I made this demo, because now I have a self-charging motor. You can see this is the long line, this is the battery, this is the wire. I will give you a drawing what is the exact setup, so you can follow what I'm saying. Okay, so this is the drawing. Give me the pen. Pen a little bit. Here is our. Give mo akong red and black. Okay, this is the battery. This is the negative side. There's a lot, so many battery here. How many? It's the total of battery in series. How many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So end of the charging, we are only 8, but we should 11, but I have no more battery of the same size. So but here, this is times 11. And here my circuit is always, there is a capacitor. This is ambient capacitor, and this one connected to a switching module. This is a switching module, and then connected here, and then this is the motor. That's exactly what and this battery connected to a set of battery, that one, that's parallel. That's a lot. It should be 11, but I don't have any more battery, so what we have now is just 8. So here, and this is connected here. So this is the positive side, and this is the positive side. Whatever circulating current here, let's say 20 ampere, example, 20 ampere, the discharge here is 20 ampere, and as well the charge here is 20 ampere, because it's already in parallel, and at the same time we should run the motor. And this motor, there is a load, the dynamo. Actually it's not a dynamo, it's a motor with bulb load of how much? 1000 watts. So 10 pieces of 100 watts, so it's 1000 watts. So this is our load, and this is the motor. So if you look here, it's exactly, if I will remove, it's actually, it's just a series, it's a loop. But the the difference here, every time I pulse it, this is, let's say this is a switch here, there is a switch here like that. Every time I switch, this capacitor always charges more than the battery. If there's 11, how many times 11? 120, 132. The total is 132 volts. But this one go to maybe more than 500 volts. I will check, and then we have the oscilloscope. But this one is a series of capacitor. That one. So we will check one by one. So here, so this is the negative side. Go to that module, and that module connected, there's a connection in by switching on this capacitor, and this one go to the this is my reactor, this is my antenna actually, and go back there, and with a module, switching module. And this one, look, again I will bring this. So I put some meter here. This meter is not accurate because we just shunt some, you know, it's not equivalent, but we don't have a good ammeter, so we just use this, you know. And look here, this is the positive side, that one, and this connected to the positive here, and this is the negative, and this one connected here, and the positive side is parallel, so down here, just look, it's connected, and this one connected here, and this one connected here, and down parallel down here. So we have total 8 parallel battery, but no problem, I can make it 11. And after that, this negative side, this negative side connected to the motor. This is the terminal of the motor. This is the big one, and there is some capacitor also, but basically this is the connection. So every time on this way, every time I pulse the motor, I'm charging the battery. So this one at this time on our testing is just 8 because I don't have any more 3 set of battery to parallel it. But anyway, we can check it now. And this motor, BLDC motor, act like a dynamo, and this is the connection, and then that's the 2000 watts bulb. Okay, this is my top secret switching module that resonate my antenna to charge this one. Okay, so we can start now. And oscilloscope. But before we start, this is our oscilloscope. But before we connect it, the job of this oscilloscope will just to measure the voltage of this, because using an ordinary voltmeter will not give us an accurate reading. So we need an oscilloscope to accurately measure the comparison of the 11 battery voltage or 132 volts, and then the voltage of the capacitor. This is series. Look, don't forget, this is a series. Connect here. We are only allowed to measure one capacitor, because if I will measure to here, it's too high and the static was so great, it will damage my oscilloscope. Don't forget, my oscilloscope, this is the 7 oscilloscopes I have, and the 6 was damaged. And most of my multimeter, AC, whatever, multimeter, digital, analog, all was damaged because of measuring accidentally before I know how to, you know, to measure this safely. But now, first, we'll disconnect that one. So we just run it here. Okay, switch on. So look. Now load, and this one is running the motor. So look here. This one, I don't know how much. Okay. So there is one bulb. It's not. I should put some. It's changing one bulb. So here is the reading. Now that's the 10 bulb. Okay, switch off. Look here. Okay, switch off. This one represents something like more or less 20 ampere. 15 to 20 ampere. More or less, or maybe 15 ampere. I don't know. We don't have, because my digital ammeter was damaged already, so we're just using not exact calibrated ammeter. So again, I will start again here. The issue here is this: since the ammeter was positioned here and the battery was here, so it means 11 batteries in series, and this is 8 all ampere. If this is 20 ampere, let's say we give some 20 ampere, what's discharging? It's the one charging this while we are running the motor. Okay, I will switch again. Okay, switch again. Ammeter. So that's the dynamo. That's the load. So now we will measure the voltage on the capacitor. This side, this one. The first, although one, that's how many? 1, 2, 3, 4, 5. So this is 5 series capacitor, so we will measure what is the indication here. Okay, now. Look, here it's occupying how many frames? Oh, that's look. Here, 1, 2, 3, 4, 5, almost 6 frames. The amplitude of the voltage of that capacitor. That's AC, you know, because I have the ambient. I'm collecting energy from the ambient. It's an AC. So you must remember that 6 frame. 1, 2, 3, 4, 5, 6. Now we will measure the battery. Switch off, switch off. Now measure the battery, end to end of the 11 batteries. Okay, since this is the terminal, the terminal, so you will connect there and that one. Okay, the end of the positive and the end of the negative, and then we need a clip. So and then we will clip. Okay, we're gonna bring this oscilloscope here. We don't need to run the unit, the system, since we are just measuring the battery. But anyway, we will run while we are measuring. So we are measuring the negative side. So here we are measuring this side, and then that one. What is the reflection here on the oscilloscope? See? That's not AC. Okay, I will put it on DC. Okay, Okay, connect it. Nothing. Okay, now, okay, we will check. We will run it. Connect it. Connect, and then we will run it to make sure that, because this is a pulsating supply, so we can see here what is the amplitude on the oscilloscope. Okay. Oh, that's it. So now how many frames is it? 1 and 2. So only 2 frames, and comparison to 6. So 2 is to 6, so 1 is to 3. So it means the battery supplying it to there. I will connect it, and then back again here. Remove, and then measure it. The same. Now again we will measure. See the difference. But this is how many? So we will add how many? This is 6 times 5. So it means 6 times 5 is 30. How many? 6 times 5. 30 frames, and this one is just 3 frames. So it means 1 is to 10. The ratio is 1 is to 10. If I'm supplying 132 volts, it means here, because you need to add all of the capacitor, we are more than something like more than 1,000 volts on it. So you measure one by one the amplitude. Lipat-lipat ka, okay? Just measure. That's the first capacitor, second capacitor. The same. Next capacitor. The same. Next capacitor. Same. Next capacitor. That's the last capacitor. The same. So it means the total of frame will be 30 frame. Comparison to the frame of what the battery is supplying is just 3 frames. This one you cannot measure accurately, but a normal. So if this one will become discharged at this very moment, my technology, if this one starts to deplete or discharge, this one should just alternate it, replace it. So that's the technology now. But later on, this will be changed by a capacitor, a super capacitor, to automatically alternate it. So just switch off. So that's it. That's my demonstration on my self-charging battery, and I hope you understand some of the. So no doubt, whatever discharging current here is the same current receiving here. At the same time, there is a capacitor which is in series that's contributing the power to the motor. So not all this 20 ampere from the battery, or I mean the power, it's from the capacitor, because you cannot get that more than 1,000 volts from the battery. It's come from the ambient. Okay, so thank you.